Tell me about your work.
We have been exploring the use of LLMs and agents for hardware design. And in particular, I work with high-level synthesis, which is technique or tools that allow to design hardware using high-level languages like C and C++ that are usually used as software languages. And so we were exploring the use of large language models to rewrite C code such that it's synthesizable and then optimize this code for hardware generation. And so we built a framework that consists of two main parts. The first one has the objective of rewriting the code such that it's compatible with these HLS tools. And the second one is to perform design space exploration to optimize the solution for hardware. And especially the second one is like a challenging task, and we implemented it with an agentic framework. So the LLM has a bunch of tools that it can use to perform different tasks. And at every iteration, like it will choose what's the next action and call a certain tool, and then read the output of the tool and decide what to do for the next action. We implemented 6 synthetic benchmarks to provide different hardware configurations, which we can see here, some of them. So like there's some parallel executions that then converge at the end, or there might be like other kind of dependencies. The goal is to see whether the large language models can understand these dependencies and optimize the solution taking advantage of the parallelism in the data flow. We ran multiple experiments, and here we have aggregated data. The success rate here is calculated for, like we consider a success when we get a result that is synthesizable, that can be implemented in hardware. We used 3 different language models, DeepSeek V3, DeepSeek R1, and OpenAI O3 Mini. The last 2 are reasoning models, so-called, and the first one is classic language model. And like a research question here is whether like these reasoning models that are supposed to be like more advanced can actually reason about hardware and outperform the non-reasoning models. And we see like the success are higher for the reasoning models, but also the costs are much higher and the times are higher. When we come to area and latency though, we see that there's not a clear winner. We have sometimes one performs better, sometimes others perform better. And especially like in the formulations of the problems to take advantage of the parallelism, none of the model really performs very well and there's no clear winners. And another takeaway we got was that reasoning models tend to kind of overthink about complex problems and then just decide at the end to take a random action. We kind of say that no, they cannot really reason very well about hardware design, but we are excited to see when they can evolve and aid us better in the future.